March 15, 1942, Sagan, Lower Silesia. The final inspection report would never capture what Oberst Friedrich von Lindeiner-Wildau witnessed as he toured his masterpiece. Stalag Luft III stretched across 59 acres of carefully engineered containment, every detail designed to crush the escape fantasies that plagued other prison camps. Through the morning mist, wooden barracks stood elevated 2 feet above ground, positioned precisely 200 meters from double-wire fencing that German engineers calculated made tunneling mathematically impossible. No flags marked where American airmen were already excavating 30 feet beneath the frozen earth, deeper than any prisoner of war tunnel in recorded history. No visible signs revealed the industrial-scale operation unfolding in Hut 104, where Major David Jones, veteran of the Doolittle raid over Tokyo, was applying American engineering principles to problems German doctrine said couldn't be solved. Most remarkably, no surface disturbance indicated that 600 tons of excavated sand would soon be dispersed through a network coordinating 800 American officers. In the camp's technical nerve center, seismographic microphones buried around the perimeter represented Germany's most sophisticated prisoner surveillance technology. The sensitive detection equipment, capable of registering footsteps at 50 meters, was designed to identify tunneling vibrations through geological sensors that German scientists believe made escape attempts detectable within hours of commencement. The Americans were operating with capabilities the Germans didn't know existed. Not superior tools or secret materials, but organizational systems that transformed individual prisoners into nodes of a resistance network that German security doctrine never anticipated. From Detroit's automotive assembly lines to Boeing's aircraft factories, American industrial thinking was revealing itself 1,000 miles behind enemy lines. The transformation had begun the moment American airmen entered their escape-proof cages. While German officials celebrated technological superiority that would finally break Allied morale, their prisoners were already building the most sophisticated escape operation in military history. German confidence was about to encounter American ingenuity, with consequences that would shock the Third Reich's leadership and divert thousands of troops during Germany's most critical military period. The Reich Ministry of Aviation had invested 18 months perfecting what German engineers called wissenschaftliche Gefangenenhaltung, scientific prisoner containment. Every specification at Stalag Luft III reflected lessons learned from 127 documented escape attempts across German prison camps since 1940, transformed into mathematical certainties that Oberst von Lindeiner-Wildau believed made his facility absolutely impenetrable. German acoustical engineers from the University of Berlin had calibrated the seismographic detection network with precision that impressed Luftwaffe technical inspectors. The buried microphone array created overlapping surveillance zones extending 75 meters beyond the perimeter fence, sensitive enough to detect a shovel striking earth at depths German calculations proved no prisoner could practically achieve. Test excavations by German sappers confirmed that tunneling operations would register distinct seismic signatures within the first 2 meters of depth. The elevated barrack design eliminated the fundamental requirement for successful tunnel construction: concealed entrance points. German architects had studied prisoner psychology reports from Stalag Luft interrogation centers, determining that Allied airmen demonstrated typical Anglo-American impatience that prevented long-term planning beyond 6-month periods. Barracks positioned on concrete footings with 24-inch clearance created visual inspection corridors that eliminated hiding places for tunnel shafts. Von Lindeiner-Wildau's confidence stemmed from systematic analysis of previous Allied escape methods. At Stalag Luft III, British officers had attempted tunneling operations that German security detected within 48 hours using primitive listening devices. The Spangenberg Castle breakout in 1941 had been thwarted by guard patrols that discovered surface disturbances after only 3 weeks of excavation. German intelligence analysis concluded that Allied prisoners lacked the organizational discipline required for extended clandestine operations. The double fence system incorporated lessons from Reich border fortifications along the Belgian frontier. Inner warning wire at ankle height would trigger immediate guard response, while the outer perimeter fence stood 9 feet high with barbed wire coils that German tests proved required cutting tools prisoners couldn't manufacture or conceal. Guard towers positioned every 150 meters provided overlapping fields of vision that eliminated blind spots where escape preparations might occur undetected. German confidence extended beyond physical barriers to psychological warfare calculations. Luftwaffe interrogation specialists had determined that American aviators, accustomed to mechanical solutions and industrial shortcuts, would become demoralized when confronted with problems that couldn't be solved through superior equipment or manufacturing capacity. The camp's remote location in Lower Silesia, 160 kilometers from any neutral border, was selected specifically to demonstrate the futility of escape planning to prisoners whose military experience emphasized rapid technological solutions. Technical superiority manifested in details that German engineers believed demonstrated overwhelming advantages. The camp's electrical systems powered searchlights with candle power ratings that illuminated 200-meter perimeters during night operations. Generator facilities buried in reinforced bunkers couldn't be sabotaged by prisoner action, ensuring continuous surveillance capability that German calculations proved would detect any nighttime movement beyond authorized areas. Von Lindeiner-Wildau's administrative reports to Luftwaffe headquarters emphasized statistical advantages that supported German confidence. Previous American prisoners at temporary facilities had demonstrated poor security discipline. In letters intercepted by German censors, revealing escape discussions that German intelligence used to predict behavioral patterns. Allied airmen consistently attempted individual escape efforts rather than coordinated operations, suggesting organizational limitations that German command structure could exploit. The camp's construction had incorporated counterintelligence features designed by Abwehr specialists who analyzed British Special Operations executive training manuals captured in occupied France. German intelligence recognized that some Allied prisoners received survival training, but calculated that such preparation focused on immediate post-crash evasion rather than long-term imprisonment resistance. The scientific approach to containment would neutralize advantages that individual training might provide. German engineering pride reached its zenith in the tunnel detection methodology. Seismographic equipment originally developed for earthquake research had been adapted by Wehrmacht technical services for military applications, including submarine detection and artillery position identification. The same scientific principles that located enemy gun emplacements would identify prisoner tunneling with mathematical precision that eliminated guesswork from camp security operations. Food rationing calculations supported German confidence in prisoner demoralization strategies. Calories provided met minimum Geneva Convention requirements while maintaining energy levels insufficient for sustained physical labor like tunnel excavation. German nutritionists had determined that Allied prisoners, accustomed to abundant American rations, would experience psychological deterioration that reduced motivation for escape planning within 90 days of captivity. The administrative structure reflected German organizational superiority that von Lindeiner-Wildau believed would overwhelm any resistance efforts prisoners might attempt. Security protocols required multiple authorization levels for routine activities, creating bureaucratic complexity that German command theory predicted would frustrate American prisoners trained in rapid decision-making environments. Every aspect of daily life operated through systematic controls that demonstrated German efficiency while highlighting prisoner dependency. By March 1943, 1 year after opening, Stalag Luft III had achieved the results German planners anticipated. No successful escapes had occurred despite housing 1,500 Allied officers who represented the most motivated potential escapees in German custody. Intelligence reports indicated declining escape discussions among prisoners, suggesting that scientific containment methods were achieving their intended psychological effects. German confidence had reached absolute certainty. The escape-proof camp was functioning exactly as designed, containing Allied airmen through technological superiority and methodical security procedures that eliminated traditional escape possibilities. Von Lindeiner-Wildau's reports to Berlin described a model facility that could be replicated across the Reich, finally solving the persistent problem of prisoner containment through German engineering excellence. What German intelligence had failed to detect was already transforming their prison into headquarters for the largest prisoner resistance operation in military history. While German intelligence reports described declining escape motivation among American prisoners, Major David Tokyo Jones was implementing organizational principles that would have impressed executives at Ford Motor Company. The Doolittle raid veteran, shot down over occupied Europe after his historic bombing mission over Japan, brought combat leadership experience to problems German psychologists believed would demoralize individual prisoners through systematic isolation. Jones understood what German analysts had missed. American military doctrine emphasized adaptive problem-solving through systematic resource allocation and coordinated team operations. The same principles that enabled Boeing to produce B-17 flying fortresses on assembly lines could transform scattered prison materials into industrial-scale resistance operations. German confidence in prisoner demoralization had encountered American organizational culture that treated obstacles as engineering challenges requiring methodical solutions. Lieutenant Colonel Albert P. Clark, designated Big S for security operations, established counterintelligence procedures that rivaled OSS training protocols. Clark's background in military intelligence provided operational security frameworks that German camp surveillance never anticipated from prisoners' German doctrine classified as contained and neutralized. His security network monitored German guard patterns with precision that mapped every patrol route, shift change, and behavioral characteristic of camp personnel. The X organization emerged as a corporate structure that German prison administrators couldn't comprehend. Squadron leader Roger Bushel, designated Big X, as overall commander, coordinated departmental operations through American prisoners who brought specialized skills from civilian careers in engineering, manufacturing, and logistics. German intelligence had focused on military ranks, while ignoring industrial expertise that American conscription had concentrated within Allied prisoner populations. Tunneling operations reflected American mining and construction methodologies that German security calculations never considered. The three-tunnel project, designated Tom, Dick, and Harry, operated simultaneously through work crews organized like industrial shifts. American prisoners applied railroad construction techniques learned from civilian employment, creating underground trolley systems that moved excavated materials through 320-foot tunnels with efficiency that German engineers would have recognized as professional-grade excavation. Sand disposal operations demonstrated American logistics thinking applied to covert resistance. The 600 tons of excavated material required systematic distribution that avoided detection by German security patrols who monitored surface disturbances around barracks foundations. American prisoners developed penguin teams, named for their waddling movement with sand-filled trouser bags, that dispersed materials through coordinated routes timed to avoid guard observation patterns. Document forgery operations functioned like American printing facilities, producing over 7,000 forged papers through improvised equipment the German camp inspections never detected. American prisoners with civilian experience in graphic design and printing established production lines that manufactured identity cards, travel permits, and work authorizations with quality standards that fooled German border controls. The forgery workshop operated through shift schedules that maintained continuous production while avoiding German security sweeps. Intelligence gathering created information networks that German counterintelligence doctrine said couldn't exist among isolated prisoners. American observation teams tracked German personnel schedules, supply deliveries, and communication patterns through systematic surveillance that provided operational intelligence for escape planning. Guard behavior analysis identified security vulnerabilities during shift changes and meal periods that German military routine inadvertently created. Tailoring operations transformed German-issued uniforms into civilian clothing through techniques that American prisoners learned from textile industry employment. Sewing workshops converted military materials into German worker clothing, using dyes extracted from library books and garden vegetables to achieve color accuracy that would pass German police inspection. The clothing production required coordination between multiple specialized teams that operated like garment manufacturing assembly lines. Radio construction demonstrated American electronics expertise that German intelligence surveys had failed to identify among prisoner populations. Howard Kundal, formerly employed in American radio manufacturing, constructed shortwave receivers from components salvaged throughout the camp. The communications equipment maintained contact with London intelligence services, providing operational coordination that German security doctrine said was impossible from isolated prison environments. The scope of American organization shocked German administrators who discovered escape preparations during routine inspections. German reports to Berlin described prisoner capabilities that exceeded Wehrmacht intelligence estimates by orders of magnitude. Camp security had been designed to contain individual escape attempts, not coordinate resistance operations involving over 800 prisoners working in specialized departments with military precision. Financial operations supported escape activities through economic systems that German prison administration never anticipated. American prisoners established currency exchanges that converted German camp money into materials required for tunnel construction and document production. Trading networks acquired tools, paper, and chemicals through systematic negotiations with German guards who underestimated prisoner organizational capabilities. Food production supported extended operations through agricultural techniques that American prisoners learned from farming backgrounds. Victory gardens established within camp boundaries provided vegetables that supplemented German rations while creating cover for tunnel ventilation systems. The agricultural operations required coordination between multiple work details that functioned like agricultural cooperatives. Training programs prepared escapees for operations beyond German prison walls through instruction that replicated military survival schools. American prisoners with specialized knowledge taught escape and evasion techniques, language skills, and navigation methods through educational programs that German camp administration interpreted as recreational activities. The training operations created expertise levels that German intelligence believed couldn't be achieved within prison environments. Quality control systems ensured operational security through inspection procedures that American prisoners adapted from industrial manufacturing standards. Every tunnel construction phase, forged document, and civilian clothing item underwent verification processes that prevented defects from compromising escape operations. The systematic approach to quality assurance reflected American industrial culture that German prison psychology studies had failed to anticipate. Communication systems coordinated departments through networks that German security surveillance couldn't detect. American prisoners established coded message systems using library books, recreational activities, and daily conversations that transmitted operational information throughout the camp. The communication networks operated through redundant channels that maintained coordination despite German efforts to limit prisoner interactions. By spring 1943, American industrial thinking had transformed Stalag Luft III from a containment facility into headquarters for resistance operations that German intelligence doctrine said couldn't exist. The systematic approach to escape planning reflected organizational capabilities that German prison psychology had dismissed as impossible among demoralized prisoners isolated from military command structures. German confidence in scientific containment was about to encounter American systematic engineering applied to problems German security had never imagined prisoners could solve. October 1943. German technical inspections discovered construction capabilities that Wehrmacht engineering manuals said couldn't exist within prisoner environments. Harry Tunnel had reached 30 feet below ground level. Twice the depth German seismographic calculations determined was achievable without industrial excavation equipment. The precision-cut wooden shoring system revealed carpentry techniques that German camp administration had never detected during routine barrack inspections. Underground railway systems shocked German engineers who examined captured tunnel sections after discovering Tom Tunnel in September 1943. American prisoners had constructed trolley tracks from bed slats and metal strips, creating transportation infrastructure that moved excavated materials through 200-foot distances with mechanical efficiency. The trolley cars, built from food containers and scavenged wheels, demonstrated manufacturing precision that German intelligence reports had dismissed as impossible using prison workshop facilities. Ventilation engineering revealed American technical knowledge that German prison psychology studies never anticipated among aircrew personnel. The air circulation systems incorporated principles from mining engineering that maintained breathable atmosphere at tunnel working faces 320 feet from entrance points. Pump mechanisms created from sports equipment and kitchen implements generated airflow through improvised ductwork that German ventilation calculations proved should have resulted in fatal carbon dioxide accumulation. Structural analysis of tunnel construction revealed American engineering standards that exceeded German military fortification requirements. Wooden supports were precisely cut and fitted using improvised measuring tools that achieved tolerances within millimeters. The shoring systems distributed load-bearing stresses through mathematical calculations that German engineers recognized as professional-grade structural engineering, executed with precision that prison workshop limitations should have made impossible. Survey accuracy shocked German technical investigators who mapped completed tunnel sections using Wehrmacht engineering equipment. Harry Tunnel maintained straight-line accuracy across 320-foot distances despite construction in complete darkness using improvised navigation tools. The directional precision required trigonometric calculations that German educational assessments suggested American aircrew personnel lacked the mathematical training to perform accurately. Electrical systems within tunnels demonstrated American technical capabilities that German camp electrical inspections had failed to detect. Improvised lighting circuits powered by batteries salvaged from multiple sources provided illumination for construction work at tunnel faces. The electrical installations included safety switches and insulation techniques that prevented short circuits, which German electrical theory predicted would occur within the humid tunnel environment. Document production capabilities revealed American printing expertise that German intelligence surveys had missed during prisoner classification procedures. The forgery workshop produced over 7,000 authentic-appearing documents using improvised printing plates carved from soap bars and wooden blocks. Paper aging techniques achieved authentic appearance through chemical processes that German document security specialists recognized as professional counterfeiting methods. Photography equipment constructed from prison materials enabled document reproduction that German security services initially mistook for authentic governmental papers. Camera mechanisms built from spectacle lenses and improvised shutters produced photographic quality that German technical analysis confirmed met professional standards. The photographic processing used chemicals extracted from medical supplies and cleaning materials through formulas that required advanced chemistry knowledge. Map reproduction operations demonstrated cartographic precision that German intelligence had determined was impossible without surveying equipment and geographical references prisoners couldn't access. American prisoners created navigation aids accurate to German military map standards using memory reconstruction and mathematical projection techniques. The cartographic accuracy enabled escaped prisoners to navigate across occupied territory using maps German border guards couldn't distinguish from official documents. Textile production revealed American industrial capabilities applied to clothing manufacture within prison workshop constraints. Dye chemistry extracted from library books, garden materials, and medical supplies achieved color matching that fooled German police inspection during escape attempts. The textile processing required knowledge of industrial chemistry that German educational assessments suggested American military personnel didn't possess. Tool manufacturing demonstrated American metalworking capabilities using materials German camp security believed couldn't be fashioned into functional implements. Digging tools constructed from kitchen utensils and metal salvage proved more effective than German military entrenching equipment. The tool production required metallurgical knowledge that German technical intelligence had failed to identify among prisoner populations. Communication equipment construction shocked German signals intelligence specialists who discovered radio receivers capable of long-distance reception using components salvaged throughout the camp. The electronic devices demonstrated circuit design knowledge that German technical education assessments indicated American aircrew training didn't include. Radio operation maintained contact with Allied intelligence services through transmission schedules that German monitoring equipment couldn't intercept. Timing mechanisms created for tunnel operations achieved precision that German chronometer specialists confirmed met military standards. Improvised timing devices constructed from alarm clock components enabled coordination between multiple tunnel crews working simultaneous shifts. The mechanical precision required watchmaking expertise that German prisoner skill assessments had determined was unavailable among Allied aircrew populations. Construction project management coordinated 3 simultaneous tunnel operations through scheduling systems that German industrial organization specialists recognized as professional engineering project control. Work crew rotation, material allocation, and progress monitoring functioned like American construction industry operations scaled to prison environment constraints. The management systems maintained operational security while achieving construction progress rates that German calculations determined were impossible without powered excavation equipment. Quality control procedures ensured construction standards that German technical inspections confirmed met military engineering specifications. Every tunnel section underwent structural verification using improvised testing methods that identified potential failure points before collapse could occur. The systematic quality assurance reflected American industrial culture applied to engineering projects German prison administration never anticipated prisoners could attempt. German technical reports to Berlin described prisoner capabilities that exceeded Wehrmacht intelligence estimates for American aircrew training programs. The engineering knowledge demonstrated by tunnel construction, document production, and equipment manufacture suggested educational backgrounds that German intelligence services had failed to identify during capture interrogation procedures. Oberst von Lindeiner-Wildau's confidence in scientific containment collapsed when German engineering analysis confirmed that American prisoners possessed technical capabilities that prison security doctrine said couldn't exist. The technological achievements represented American industrial education applied to problems German military psychology believed would demoralize individual prisoners through systematic isolation. German engineers faced the shocking realization that American aircrew training included technical education that enabled industrial-scale resistance operations using materials German prison administration considered harmless. The technological capabilities revealed organizational systems that German intelligence doctrine had never anticipated among captured military personnel. The escape-proof camp was about to discover that American technological ingenuity could defeat German scientific containment through engineering solutions German security calculations never imagined prisoners could achieve. March 24, 1944, 22:30 hours. German guard reports would never adequately describe what Hauptmann Hans Pieber witnessed when he discovered the empty tunnel entrance in Hut 104. The wooden trapdoor, camouflaged beneath a heating stove that German security inspections had examined dozens of times, opened onto a shaft that descended into darkness. German engineering calculations said couldn't exist. The escape had been executing for 4 hours without triggering a single German detection system. 76 Allied officers were moving through Harry Tunnel in precisely timed intervals, one man every 12 minutes, coordinated by stopwatch timing that maintained operational security despite weather conditions German meteorologists described as the worst winter storm in 30 years. 5 feet of snow covered the camp, creating surface conditions that German planners believed made escape attempts suicide missions. Piber's flashlight beam revealed construction that German technical intelligence had declared impossible. The tunnel entrance chamber showed professional excavation work extending 30 feet below ground level, bypassing seismographic detection equipment that German acoustical engineers guaranteed would identify any digging operation within 48 hours. Wooden shoring systems demonstrated carpentry precision that German camp workshops supposedly couldn't achieve using available materials. German security doctrine collapsed within minutes of discovery. The sophisticated timing system that moved escapees through 320-foot underground passages had operated undetected throughout the night shift, defeating guard patrols that German security calculations proved provided complete surveillance coverage. Every German assumption about prisoner capabilities, tunnel construction possibilities, and detection system reliability disintegrated when confronted with American execution precision. The tunnel exit point, discovered at dawn 200 meters beyond the outer perimeter fence, revealed German intelligence failures that Wehrmacht security doctrine never anticipated. American prisoners had achieved survey accuracy that placed the exit precisely outside German security zones, requiring navigational calculations. German educational assessments indicated aircrew personnel lacked the mathematical training to perform. The exit location demonstrated reconnaissance capabilities that German counterintelligence procedures should have detected during months of preparation. German communications networks failed to coordinate effective response procedures when confronted with escape operations that exceeded all previous experience. Camp telephone systems designed to alert regional security commands within minutes of escape attempts became overwhelmed by the scale of prisoner breakout that German planning scenarios never envisioned. Alert procedures developed for individual escape attempts proved inadequate for mass breakout operations involving 76 coordinated escapees. Weather conditions that German meteorologists believed would prevent escape attempts had been incorporated into American operational planning with precision that shocked Wehrmacht weather analysis specialists. The blizzard conditions that reduced visibility to 50 meters provided concealment for escape operations, while German guard procedures assumed prisoners would abandon outdoor activities during severe weather. American timing had exploited German meteorological overconfidence in weather as natural security barrier. Hauptmann Piber's inspection of tunnel construction revealed American engineering capabilities that German technical intelligence had failed to identify among prisoner populations. The underground railway system included trolley mechanisms that transported escapees through tunnel sections with mechanical efficiency, German engineers recognized as professional-grade transportation engineering. Cartwheels manufactured from kitchen equipment demonstrated metalworking precision that prison workshop limitations should have made impossible. German guard interrogations revealed security failures that Wehrmacht doctrine insisted couldn't occur within properly administered prison facilities. Multiple guard shifts had observed normal prisoner activities throughout the escape night, unaware that coordinated resistance operations were defeating surveillance systems German security specialists believed provided complete camp monitoring. The systematic deception required operational security training that German intelligence assessments determined American aircrew personnel didn't receive. Dawn reconnaissance flights revealed escape dispersal patterns that demonstrated American evasion training beyond German educational estimates for Allied aircrew preparation. 76 escapees had scattered across occupied territory using navigation techniques that required geographical knowledge and survival skills German military intelligence believed weren't included in American aviation training programs. The dispersal coordination suggested pre-planned escape routes developed through intelligence gathering. German counterintelligence procedures should have detected. Regional security commands discovered the scope of German intelligence failure when escape reports arrived from locations across occupied Europe. American prisoners were appearing at checkpoints hundreds of kilometers from Stalag Luft III, using forged documentation that German border security initially accepted as authentic governmental papers. The document quality revealed counterfeiting expertise that German intelligence surveys had failed to identify among captured aircrew personnel. German investigation teams found evidence of prisoner capabilities that Wehrmacht security doctrine said couldn't exist within isolated prison environments. Tool manufacturing using improvised materials had achieved precision that German metallurgical analysis confirmed met industrial standards. Chemical processing for document aging and textile dyeing demonstrated knowledge of industrial chemistry that German educational assessments indicated American military training didn't include. Oberst von Lindeiner-Wildau's emergency reports to Berlin described security system failures that German prison psychology never anticipated. The seismographic detection network had been defeated by construction techniques that achieved depths German acoustical calculations proved should trigger automatic alerts. Tunnel ventilation systems had maintained breathable atmosphere across distances. German engineering formulas determined would result in fatal carbon dioxide accumulation. German technical specialists discovered that American prisoners had achieved construction project coordination that exceeded Wehrmacht engineering project management standards. 3 simultaneous tunnel operations had been managed through scheduling systems that maintained operational security while achieving progress rates German calculations determined were impossible without powered excavation equipment. The project management demonstrated organizational capabilities that German intelligence doctrine insisted couldn't develop among demoralized prisoners. Security system analysis revealed that German confidence in technological superiority had been systematically defeated by American industrial thinking applied to escape operations. Every German advantage, seismographic detection, elevated barracks, perimeter surveillance, had been countered by engineering solutions that prison workshop constraints should have prevented. American prisoners had achieved technical capabilities that German security planning never imagined possible. The psychological impact on German personnel extended beyond immediate operational failures to fundamental questioning of Wehrmacht intelligence capabilities. Guard units that had maintained confidence in scientific containment methods experienced morale collapse when confronted with escape operations that exceeded all previous prisoner resistance examples. German security doctrine required complete revision when faced with American organizational capabilities that prison psychology studies never predicted. Regional commanders discovered that 76 coordinated escapees required security response beyond German occupation force capabilities. Thousands of Wehrmacht troops were diverted from frontline operations to conduct manhunt operations across occupied Europe, creating strategic impact that German military planners never anticipated from contained prisoner populations. The resource diversion occurred during critical periods when German forces faced increasing Allied pressure on multiple fronts. By March 25th dawn, German confidence in scientific prison containment had been shattered by American execution precision that defeated every technological advantage German engineering had created. The escape-proof camp had been transformed from symbol of German technological superiority into demonstration of American industrial capabilities applied to resistance operations that Wehrmacht intelligence doctrine never imagined prisoners could achieve. The night that was supposed to prove German containment superiority instead revealed that American organizational culture could defeat German technological advantages through systematic engineering solutions that prison security calculations never anticipated. March 26, 1944. Führerhauptquartier, East Prussia. Hitler's morning briefing would never adequately convey the strategic disaster that Wehrmacht intelligence officers described when reporting the Stalag Luft III breakout to German high command. 76 Allied prisoners had achieved coordination that German military doctrine said required division-level staff planning, executed through resistance operations that Wehrmacht security specialists believed were impossible within isolated prison environments. The Führer's rage extended beyond immediate security failures to fundamental questions about German intelligence capabilities throughout occupied Europe. If American prisoners could organize industrial-scale resistance operations under constant surveillance, what capabilities did Allied intelligence networks possess in civilian populations that German occupation forces assumed were controlled? The strategic implications threatened German confidence in occupation security across conquered territories. Reichsführer SS Heinrich Himmler's emergency directives revealed the scope of strategic resource diversion that German military planners never anticipated from contained prisoner populations. Over 70,000 Wehrmacht troops, Gestapo agents, and police units were immediately reassigned from frontline operations to conduct manhunt operations across occupied Europe. The security response required forces equivalent to 2 full divisions during critical periods when German armies faced increasing Allied pressure on multiple fronts. German intelligence services discovered escape coordination that exceeded Wehrmacht estimates for Allied special operations capabilities. The systematic prisoner dispersal across occupied territory suggested pre-planned escape routes developed through intelligence gathering that German counterintelligence doctrine insisted couldn't occur within prison environments. Regional security commands reported escaped prisoners appearing at checkpoints with forged documentation that German border security initially accepted as authentic governmental papers. Transportation networks throughout occupied Europe experienced disruption that German logistics specialists never calculated in strategic planning scenarios. Railroad security required additional personnel to inspect travelers whose documentation might conceal escaped prisoners using American counterfeiting capabilities that German intelligence surveys had failed to identify. Highway checkpoints demanded increased staffing to examine civilian workers whose appearance might disguise Allied escapees using German clothing manufactured through techniques prison workshops supposedly couldn't achieve. The strategic impact extended to German industrial production when security concerns required worker verification procedures that reduced factory efficiency throughout occupied territories. Manufacturing facilities employing foreign workers implemented additional security protocols to prevent escaped prisoners from infiltrating industrial operations critical to German war production. The productivity reduction occurred when German factories faced increasing demands for military equipment to replace losses on expanding battlefronts. German military intelligence faced systematic revision of threat assessment procedures when confronted with American organizational capabilities that Wehrmacht doctrine never anticipated among captured personnel. Previous intelligence estimates for Allied special operations training proved inadequate when American aircrew demonstrated coordination abilities that exceeded German commando unit standards. The capability assessment failures required fundamental changes to security planning throughout German-occupied Europe. Hitler's directive to execute 50 recaptured escapees reflected strategic panic that German leadership experienced when discovering American resistance capabilities that Wehrmacht psychology studies said couldn't develop among demoralized prisoners. The execution order, transmitted directly through SS channels bypassing military command structure, demonstrated German recognition that conventional prisoner containment methods had failed against American industrial thinking applied to resistance operations. Regional commanders discovered that German occupation forces lacked sufficient personnel to maintain both frontline military operations and comprehensive manhunt activities required by the escape aftermath. Security operations in France, Belgium, Netherlands, and Poland demanded troop concentrations that weakened German defensive preparations against anticipated Allied invasion operations. The resource diversion created strategic vulnerabilities that German military planning never envisioned from prison camp security failures. German intelligence analysis revealed that American escape operations had achieved strategic coordination beyond Wehrmacht capabilities for similar operations within enemy territory. The systematic planning, resource allocation, and execution precision demonstrated organizational culture that German military education specialists determined exceeded German special forces training standards. American prisoners had applied industrial management techniques to resistance operations with results that shocked German command structure. Communication intercepts revealed German security system failures extending beyond immediate prison camp boundaries to occupation-wide intelligence gathering capabilities. Allied intelligence networks throughout occupied Europe had maintained contact with escaped prisoners through communication systems that German signals intelligence couldn't detect or intercept. The communication security demonstrated Allied technical capabilities that German electronic warfare specialists never anticipated among resistance organizations. The psychological impact on German leadership extended to fundamental questioning of Wehrmacht intelligence assessments for Allied military capabilities. If American aircrew possessed organizational training that enabled industrial-scale resistance operations, what capabilities did Allied ground forces possess that German military intelligence had failed to identify? The strategic implications required reassessment of Allied military potential across all combat theaters. German occupation policies underwent emergency revision when confronted with American resistance capabilities that threatened security assumptions throughout conquered territories. Prisoner containment procedures required systematic upgrading that demanded resources and personnel German strategic planning couldn't accommodate without reducing military operations against Allied forces. The security enhancement needs created strategic burden that German command structure never anticipated from prison administration requirements. Industrial intelligence services discovered that American prisoners possessed technical knowledge that exceeded German educational estimates for Allied military training programs. The engineering capabilities demonstrated through tunnel construction, document production, and equipment manufacture suggested American industrial education systems that produced military personnel with capabilities German intelligence doctrine never recognized. The educational assessment failures required complete revision of Allied capability estimates. German strategic planning faced disruption when escape aftermath operations demanded resources allocated for military operations against Allied invasion preparations. The manhunt requirements forced German command to choose between maintaining occupation security and concentrating forces for defensive operations against expected Allied strategic offensives. The resource allocation dilemma created strategic vulnerabilities that German military planning never envisioned from prison security failures. By April 1944, the strategic catastrophe extended beyond immediate escape consequences to systematic questioning of German intelligence capabilities throughout the war effort. American organizational thinking applied to resistance operations had achieved strategic impact that German military doctrine insisted was impossible from isolated prisoner populations. The resource diversion and psychological impact created strategic burden that weakened German military capabilities during critical periods of Allied offensive preparation. The escape-proof prison had been transformed from symbol of German technological superiority into strategic liability that demonstrated American industrial capabilities could defeat German security systems through systematic engineering solutions that Wehrmacht intelligence never imagined prisoners could achieve. German confidence in occupation security had been fundamentally undermined by American prisoners who applied industrial organization techniques to resistance operations with strategic consequences that shocked German high command. The strategic realization emerged that American industrial culture could produce military personnel whose capabilities exceeded German intelligence estimates, threatening German assumptions about Allied military potential across all theaters of operations. Fort Hunt, Virginia, 1943. The classified MI6 facility would never appear in wartime production statistics, but Lieutenant Colonel Melvin Purvis's operation was manufacturing escape aids with industrial precision that German intelligence services never suspected existed. While Wehrmacht planners calculated prisoner containment based on isolation from external resources, American factories were mass-producing survival equipment specifically designed to reach Allied prisoners through systematic supply networks that German security doctrine never anticipated. The scope of American industrial commitment to prisoner support shocked German intelligence analysts who discovered MI6 production capabilities during post-war investigations. 5 million uniform buttons containing hidden compasses had been manufactured by American precision instrument companies and distributed to aircrew personnel before capture. The production volume represented manufacturing coordination between military procurement and civilian industry that German economic planners never achieved for specialized military equipment. Silk escape maps printed with chemical inks that remained invisible until activated by prisoner urine demonstrated American industrial chemistry applied to covert operations with manufacturing precision that German technical intelligence couldn't duplicate. The Ethyl Corporation and DuPont chemical facilities produced over 3.5 million maps using printing techniques that required industrial coordination between textile manufacturers, chemical processors, and military distribution networks. Playing cards containing escape route information were manufactured through coordination between Bicycle Playing Card Company and military intelligence services, achieving distribution volumes that reached tens of thousands of American prisoners throughout German camps. The industrial partnership demonstrated American manufacturing flexibility that converted civilian production facilities to specialized military applications with efficiency German war economy planners never accomplished. American industrial culture had extended prisoner support operations to scales that German military production couldn't comprehend. Monopoly game sets containing real currency, metal files disguised as pencils, and razor blades hidden in combs represented systematic manufacturing coordination that transformed American toy and personal care industries into covert military supply networks. The production coordination required industrial management capabilities that German economic planners recognized as superior to Wehrmacht logistics systems. The Stalag Luft III escape had revealed American organizational principles that extended far beyond individual prison camps to systematic industrial approaches that German economic doctrine never anticipated. Major David Jones and Lieutenant Colonel Albert Clark had applied American corporate management techniques to resistance operations with results that demonstrated industrial thinking could defeat German technological advantages through systematic resource allocation and coordinated team operations. Post-war analysis by German industrial specialists revealed that American prisoner resistance capabilities reflected broader manufacturing culture that produced military personnel whose technical knowledge exceeded German educational estimates. The engineering capabilities demonstrated through tunnel construction, document production, and equipment manufacture suggested American industrial education systems that German intelligence services never properly assessed during capability evaluations. German economic planners discovered that American industrial capacity extended to specialized military applications that Wehrmacht production couldn't match. While German factories struggled to produce sufficient radios for tank units, American manufacturers were supplying covert communication equipment to prisoners through distribution networks that operated across occupied Europe. The industrial coordination demonstrated manufacturing flexibility that German war economy never achieved. The strategic implications extended beyond immediate prisoner support to fundamental questions about American industrial capabilities that German economic intelligence had systematically underestimated. If American manufacturers could coordinate covert supply operations for prisoners while maintaining civilian production and military equipment manufacturing, what production capabilities did American industry possess that German economic planning never anticipated? American industrial thinking had transformed prisoner resistance from individual survival efforts into coordinated operations that achieved strategic impact through systematic application of manufacturing management principles. The organizational culture that enabled Ford Motor Company to produce B-24 bombers and Liberty ships also enabled American prisoners to defeat German security systems through industrial approaches to resistance operations. The legacy of Stalag Luft III extended to post-war recognition that American industrial education had produced military personnel whose capabilities exceeded German intelligence estimates across all technical specialties. The engineering knowledge, organizational skills, and systematic thinking demonstrated by American prisoners reflected educational systems that prepared civilian workforce for military applications German training never achieved. German post-war economic analysis concluded that American industrial culture had created systematic advantages that extended from factory production floors to prison camps behind enemy lines. The same manufacturing principles that enabled American industry to outproduce German factories also enabled American prisoners to organize resistance operations that defeated German security systems through superior organizational coordination. The escape-proof prison had encountered American industrial thinking applied to problems German engineering believed were impossible to solve using available resources. The systematic approach to resistance operations reflected manufacturing culture that treated obstacles as engineering challenges, requiring methodical solutions through coordinated team efforts and systematic resource allocation. The final recognition emerged that American industrial superiority extended beyond production statistics to organizational culture that enabled systematic problem-solving capabilities German economic doctrine never anticipated. The prisoners who defeated German scientific containment represented industrial education systems that produced military personnel whose capabilities exceeded German intelligence estimates throughout the entire war effort. American industrial might had reached even into German prison camps, transforming containment facilities into demonstrations of systematic American advantages that German leadership never imagined possible.